Namaste and welcome back to the Data Structures and Algorithms classes. My dear friends, today we are going to be learning about a very exciting concept called as bit manipulations, right? You know that after all, what you call as a computer is a world of zeros and ones, or what you call as bits. Hence, as a programmer, knowing how to work with bits becomes a very important skill set to have. In these series of lectures, we are going to learn about how to manipulate bits. We are going to be learning about bitwise operators, and we are going to be solving a lot of programs where you will be making use of the knowledge of bitwise operators and manipulations that you learned to write extremely efficient programs. Well, having that out of the way, now let's start with a very fundamental fact. Let us assume you want to store a value like 45 inside your program, right? Now 45 is data. Now, in order for you to store data, every programming language provides you a concept of data types, and let us assume we make use of the byte data type to store it, right? Of course, if you're using a dynamically typed programming language like Python, then you don't even have to worry about declaration of data type. Python will automatically take care of it. However, those of you who are learning Java, you know you have the byte data type. Ultimately, what is a data type's duty? A data type's duty is to, number one, go into the RAM and allocate the required memory for you to store that data. And because you made use of the byte data type will allocate 1 byte on your RAM. I hope you're able to think. Now this 1 byte is a collection of 8 bits. Now the second duty of a data type is to convert the given data into zeros and ones. For that, certain formats are used. For example, all the integer data types make use of a format called as the base 2 format to perform the conversion, and then it would convert 45 into its associated binary form and store it inside the memory. Now, ultimately, if whatever data you are making use of in your program is in the form of zeros and ones in the memory, it's very important that you know how to work with those bits, because ultimately every data is in the form of bits, 0 or 1. And that is why bit manipulation becomes very important, right? So, what are we really waiting for? Let's get started. Now, before we deep dive and explore the world of bit manipulations, there are some prerequisites which I feel like you must and should have, which will give you complete clarity for the concepts going ahead. The first one is how to convert a given decimal number to binary. Guys, it's very simple. Assume the number here is 45 and I want to convert it into its binary form. Now, you have to use a technique or a format called as the base 2 format. Now, using the base 2 format, how do you convert? It's very simple. The logic of base 2 format is any given number, you have to keep dividing it by 2 till the number after dividing becomes 1. The moment it becomes 1, you take all the remainders together, add them up, and it becomes the binary number. Confusing? Very simple. Watch it. I'll take 45, I'll divide it by 2. If I divide it by 2, the quotient happens to be 22 and the remainder of the division is 1, which I will write next to it like that. Again, if I divide it by 2, quotient is 11, remainder is 0. Again, if I divide it by 2, quotient is 5, remainder is 1. Again, if in case I divide it, quotient is 2, remainder is 1. Again, if I divide it, quotient is 1, remainder becomes 0. Or in other words, 45, I've divided so many times by 2 that ultimately it has become 1. Now, from bottom to top, you must take all these bits. For example, 1, 0, 1, 1, 0, 1. Everything together I'm adding. If I add them up together, you will get the binary version of 45, which is 1, 0, 1, 1, 0, 1. I hope you're able to think. Very simple. Now that you understood how to convert decimal to binary, let me show you how to do the reverse operation, which is binary to decimal, right? Let's go and check that out. So when it comes to binary to decimal, guys, it's very simple, right? So I'm just showing you the binary equivalent of 45. It is 1, 0, 1, 1, 0, 1. Now, a simple rule you must understand. Every single bit has a 2 to the power positional value. What do you mean, sir? Very simple. Starting from the rightmost bit, it is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. Like this, if there were more bits, the power of 2 should continue. How are we able to think? Now, to convert from binary to decimal, all you have to do is identify all those bits which is set to 1. I'm marking them in a different color. See, all of them are 1. Now take 2 to the power positional value of all of them and put plus in between. Sum them up. So you know 2 to the power 5 is 32 plus 2 to the power 3 is 8 and then it is 4 and then it is 1. If I add everything together, what do you get? 45. How were you able to think? So the simple way to convert a given decimal value to binary and from binary back to decimal is clear to all of you. Now that this is out of the way, let me show you something even more interesting. Now let us go ahead and see how programmatically we will be able to convert a given number from decimal to binary. Okay, so what I'll do is I'll just go create a static function. I'll call it as decimal to binary. And yeah, decimal to binary. What it has to return later we will see. I'm leaving the return type empty. It will take one integer variable n. Now inside this I'm going to go and I'm going to do a very simple operation, right? Now understand this. What I'll do is, see, this is n, guys. So n, let us assume, is 45. What I'm going to do is I'm going to create one empty string variable called as b. Inside that string variable, ultimately our binary value is going to be there. Now why string, you may ask, you will understand. Anyways, I'll just go here and I'll tell b equal to, and I'll create one empty string. Yeah, obviously it has to be of type string, right? An empty string I've created. Great. Now, please understand what I'm also going to do is, I'm going to, this is how we will basically be proceeding, right? So what I will do is, I'll take 45, we will divide it by 2. When we divide it by 2, ultimately the quotient is going to be 22, remainder is going to be 1. Now what must happen, if you think clearly, is that one remainder is also important to us. We have to keep it somewhere. And ultimately 45 should become 22. N should change. Only then our algorithm will work. So see, what I will do is I'll come down like this. I'll create one integer variable called as x. And to x, what will I give if you ask me? I will store the remainder of n divided by 2. So watch it, equal to n mod 2 I will tell. I hope you are able to think. Obviously what is going to be stored inside x now is the remainder of this division. I hope you are able to think. In this case, x is initially going to have 1. Now next, n value should update itself. These are very important operations, so we should not miss it. See, n value from 45 should now become 22. 22 should go and sit. So how will you do that? Simple. I will take n and I will divide by 2. But if I use slash, I will not get the remainder, I will get the quotient, and 22 is the quotient, that is what I want to store, and I will tell, hey, update this as the value of n. Now what is important is, ultimately this b, to b I want to keep appending whatever, or attaching or concatenating whatever is the remainders that I get. Ultimately what I will be getting is the entire binary value. But look at this, what I will do is b equal to, and I will not tell old value of b plus x, like this I will not tell. Now you may ask, why sir, why will you not tell like this? Why I will not tell like this is for a very simple reason, which is, if you do like this, in reverse order you will not get, because you know the bits, you must take it in the reverse order. So you must tell it as x plus b, like this. I hope you are able to think. Any confusion till this point of time? So that is what I am also showing, that b is equal to x plus b. What is x value? 1. What is b? Empty string. Concat, what will you get? 1. And that is what b will be. B will now be 1. I hope you are able to think. Now, this process should repeat. Again, we have to take the updated value of n divided by 2, store the remainder in x, store the quotient in n, concatenate the remainder to b. Now the question is, how long should it keep doing? Very simple. Look at this. Now 22, if I divide by 2, I'll get 11 as the quotient, 0 as the remainder. 0 will be in x, n will become 11. If I again do it, it will be 5 and 1. 1 will be in x, 5 will be in n. And obviously, concatenation also is parallelly happening. I hope you are noticing it, right? After that, 5 will be divided by 2. Obviously, I'm going to get 2 as the quotient, 1 as the remainder. Updation will happen, concatenation will happen. And again, if I divide it, it is going to become 1. 1 and 0. So now remainder is 0, x will become 0 and n will become 1. The moment n becomes 1, we have to stop. I hope you're able to think. So as long as n value is equal to or greater than 1, keep performing this operation. And ultimately, if you keep doing that, B will ultimately have the concatenated binary string. I hope you're able to think, and that is what I am also doing. So I'll just put this, I'll tell as long as means while. As long as what? N is greater than equal to 1. I'll tell. And all these statements I'll take, put it inside that. Beautiful, easy. Now ultimately when I come out of the loop, this string is going to have the binary number. And that is what I should return. Since it is a string, I'll tell return B. And obviously the return type is going to be string. Any confusion till this point of time? Okay, great. So now the larger question is, will this work, right? Well, for that, my dear friends, watch it. What I have to now do is, I'll just call this function. If I call this function decimal to binary, and I'll put it within system.out.println. So already you can see I'm taking input, n as input. So system.out.println, decimal to binary, I'll pass n. Ultimately, it should return the binary equivalent. So if in case I execute, then obviously it is going to wait for me. I'll give 45, and if in case I press enter, it is telling 101101. And please understand, this will only happen if you tell b equal to x plus b. If you would have told b plus x, it will not work. See, I'll just go change that. I'll make it as b plus x. If I execute, then you can give some other number. You can see 32 should have actually be 1 followed by the 5 zeros, but it is 5 zeros followed by 1. Because simple, right? This is 2 to the power 0, 1, 2, 3, 4, 5. Only if 1 was here, 2 to the power 5, you would have got 32. How were you able to think? But it happened because of this. So x plus b is important. Otherwise, concatenation will not work. I hope everybody understood this perfectly. Any confusion till here? Now, if in case we have done this, then obviously it is important to us that we should be able to convert binary back to decimal. I hope you're able to think. So what I will do is, I'll just go here and cut this binary, decimal to binary, put it outside the system.out.println. Yeah, I'll just cut it and put it outside, and I'll collect it in a variable called a string b maybe for binary. Yeah, and I'll print that b. No, already a sysout is there. Let's put b inside it. Yeah, scroll. Now, what I want to do is, now I want to pass b to another function called as binary to decimal. I hope you're able to think, which should do the reverse. So I'll just go here and I'll declare that. So I'll just tell static, and obviously decimal is an integer. So int binary to decimal I will tell. Okay. Now, what could be the algorithm for this is the bigger question. Anyways, I'll just accept a string b. Okay, good. Now I'll come inside, and what I have to now do here is very simple. Guys, first of all, to have the result, that is converting back to decimal, I need a variable. So I'll just create int result, and I will initially make it as 0. Make it as 0, and as you can see, I have created that result, and initially it is 0. After this, what I'm going to do is, see, you must understand, guys, this is b. I'm just showing you b, right? So b is a string. So don't you think string is nothing but an array of characters like this? Obviously, index variables also will be there. Now, if you have to convert it, you need the 2 to the power of the position, and the position starts from the last bit there. So 2 to the power 0, 1, 2, 3, 4, 5, like that. I hope you're able to think. So you need the powers of 2 ultimately to convert it, right? So how will you do it? Simple. I'll create an integer variable called as power of 2. And the initial first value of power of 2 is 1. 2 to the power 0 is 1. So I'll make it as 1, and that is a variable I'm showing it there also. Now what I'm going to do is a very, very simple operation. What are you going to do, sir? See, look at it. I'm going to start a loop and I'll tell, hey, I start from the last character. See, I is starting from the last character. All I will do is, when should you add the power of 2, friends? Whenever the bit is 1. So when you're iterating over the loop from the end to the beginning, should you be checking for zeros or ones? Ones. So I'll just tell, if in case the character at the ith position is equal to 1, then what should I do? Then what I should do is, I should take the power of that position and I must add it to this previous value of result and update the value of result. This way ultimately result will have the final value if I keep doing this. So what I'll do is, I'll just tell result is equal to result plus power of 2, like this I will tell. Result is equal to result plus power of 2. But you must understand, the first time is I1, look at that, yes, condition is true. If condition is true, then I will come inside, old value of result is 0, the power of 2 you have initialized it as 1. So 0 plus 1 you will get 1 and that is what your result is going to be as of now. Any confusion till result is 1. Now I will move backwards, right? I will move backwards, I minus, but now tell me, look at this power of 2. Next time, if you find a 1 and you use the power of 2, you will be using the power of 2 which is 2 to the power 0, which is a mistake. So don't you think as I is moving, the power of 2 also should update itself? And that is why I will tell, how will you find the next power of 2? By multiplying the old power with 2. So all I will tell is, new power of 2 will be equal to the old power of 2 into 2, which means 2 is the old power, into 2 it will become 4, I will update it. So every time you iterate, ultimately the power of 2 should also keep increasing. So tell me, should the power of 2 increase only if in case the bit is 1, or irrespective, every time you iterate should it increase? Would you agree? Every time it should increase, it is independent of whether there is 0 or 1. So that power of 2 updation should not be inside if, it should be outside if. So see, I'm bringing the indentation to if. So you must understand what I'm trying to tell here is that irrespective of whether the bit is 1 or 0, power of 2 must increase. Any confusion till here? So that is what I'm just doing here. I'll just run a for loop. I'll tell for, and it should start from the last character. So I'll tell I is equal to s dot character, or no, I is equal to, I want the last index, isn't it? Last index is length minus 1. So length minus 1, and then I will tell go till I is greater than or equal to 0, and then I minus minus. I minus minus. Any confusion till here? Next, inside this, it's a very simple thing. If in case the character at the ith position, if it is equal to 1, then I must update the value of result. So I'll just, where is result? We have already created it. So I'll tell result is equal to old value of result plus the power of 2. Hope I'm clear. I'll come outside if, whether this condition works or not, next iteration power of 2 must be updated. So I'll tell old power of 2 is equal to new power of 2 into 2. Good. I hope I'm clear till here. Any confusion, guys? Awesome. So ultimately when I come out of the loop, result will have my decimal value. I'll return that. So I'll just tell return result. Okay, good. Now we have to call this function. So I'm just going to go down and I'll just call that function. So I will tell system.out.println, and I will tell binary to decimal, and I will pass b to it. As you can see, I have passed b to it. Now if I execute it, then like this I will get 45. If I give, I will get the binary, then binary value I am passing to binary to decimal, and it will give me back the exact value, which is 45. So both theoretically as well as practically by writing code, how to convert decimal to binary, binary to decimal is clear to all of you.